Okay, so just where we left off, I had said if the length of vector A is not 0 and the length of vector B is not 0, but A dot B is equal to 0, then it means the cos of the angle between them must be 0. And if the cos of the angle between them is 0, it means theta must be 90, which means A must be perpendicular to B. Does that make sense? Because if you have absolute value, so A dot B is equal to 0, which means the absolute value of A times the absolute value of B times the cos of the angle between them is 0. And we just said A and B weren't 0, then this must be. And if this is 0, it means theta must be 90. They must be perpendicular to each other. And some of you were saying, oh, it could be 270, but we usually measure the angle so that it's less than 180. So if it's 270 one way, it'll be 90 the other way. Okay, one other little thing to note is that A dot B is equal to B dot A. In other words, the order when you dot multiply vectors does not matter. Okay, and that'll become important because in the next one, the other type of multiplying, it does matter. But in this one, it doesn't matter. Okay, it wouldn't matter if you did 1 times 1 here or 1 times 1 the other way. Let me do a different example. Okay, so let's do a couple examples and you'll understand what the heck I'm talking about. So let's make A. We'll let vector A equal 4I plus 3j. And we'll let vector B equal negative 3I plus 5k. And so I want you to dot multiply A with B. So really what that means then is we're doing 4I plus 3j, and we're dotting that with negative 3I plus 5k. Well, really then we kind of have to FOIL. We have to multiply every term of the first vector by every term of the second vector. So it'll really be 4I dot negative 3I plus 4I dot 5k plus 3j dot negative 3I plus 3j dot 5k. Okay, so all I did was multiply the I by both terms and then the j by both terms. So the two components in the first one by the two components of the second one. Now we have to actually multiply them out. So 4 times negative 3 is negative 12, and I times I, if you remember, I times I is just 1. I dot I, 1 times the cos of 0, which is 1. So this just becomes negative 12 because this I dot I is 1. The next term, 4 times 5 is 20, but look what happens. Now you have an I dot k. What's true about I dot k? Absolute value of 1, absolute value of 1. What's the angle between the x-axis and the z-axis? It's 90 degrees. This term goes to 0. Plus 3 times negative 3 is negative 9. J dot I, again, they're perpendicular. This term goes to 0. Plus 3 times 5, 15. J dot k. Look at that, perpendicular again. This term goes to 0. So when you're dotting, the only terms that survive are the ones that dot the i's with the i's, the j's with the j's, the k's with the k's. I wrote all these out, but really I could have just done the very first term. 4I times negative 3I gives me negative 12I dot I. The final answer here is negative 12 because it's a scalar, no vector direction. Okay, let me do another one and see if that will help you. So number 2 example. Let's make A equal to 2I plus 4j plus 6k. and we'll make b equal 3i minus 5j plus 7k. And so we're going to do, again, a dot b. So really 2i plus 4j plus 6k dotted with 3i minus 5j plus 7k. Okay, so again, every term in this first vector has to be multiplied by every term in the second vector, but remember, the I dot I stays, so 2i dot 3i stays. But 2i dot 5j, that's going to be 0 because it's I dot j. 2i dot 7k, going to be 0. So I don't even have to write them down. You can if you want to get used to it and then cross them out, but you don't have to. So if you want me to for now, we can do this. So dot negative 5j, but it's going to go to 0. Plus 2i dot 7k, it's going to go to 0. So now I do the next one, 4j dot 3i. Well, j dot I, it's going to go to 0. Plus 4j dot negative 5j, that one stays. Plus 4j dot 7k, going to go to 0. They're perpendicular. Plus 6k dot 3i, again perpendicular. Plus 6k dot negative 5j, perpendicular. Plus 6k dot 7k stays. So now we go back and we say, all right, so a dot b is equal to 2 times 3, that's about 6. Plus gone, 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 2 times negative 5. That's a 4 though. So negative 20. Gone, gone, gone. 6 times 7, 42. So 20 minus 20 plus 42 is 22 plus 6. A dot b should be equal to 28. Done. Makes sense? So really, when you're dotting them, it's just the terms that are the same that stay, and all the other terms disappear because all the other terms are perpendicular. All right. Now, that's one piece. The second piece is there's an angle. So remember back on the other side, I had said we define a dot b to be the absolute value of a, absolute value of b, or the length of a, the length of b, times the cosine of the angle between them. In the last class, I had said we're going to want to find that angle, right? So, like in this question, this vector is in like a three-dimensional space, and we're dot multiplying it by this vector in three-dimensional space, not in the same plane, but we might want to know the angle between them. It would be hard as heck to find that if we didn't have our dot multiplying equation. Okay, so going back to a dot b is equal to the absolute value of a, absolute value of b times the cosine of the angle between them. We can solve for the cosine of the angle between them. It'll just be a dot b over the absolute value, or length of a, times the length of b. So if we did this one, let's start with this one up here. If we did example A, well, we already have the a dot b, it's negative 12. And then absolute value of a, so that just means the length, so which is the Pythagorean theorem, 4 squared plus 3 squared, take the square root, so that's 5. And b, is that a negative 3 squared, 9, plus 5 squared, 25, which is 34, so times the square root of 34. Okay, so do negative 12 divided by 5 times the square root of 34, and you get negative 0.41159, etc. I'm going to run out of time here. Okay, and then to find the angle, do inverse sine. Or excuse me, inverse cos would probably be a better idea. Now there's a negative there. What the heck do we do with the negative? And that's where I'm going to let you think about it until the next video. because it's